and this is a scattering experiment. We consider it an elastic collision. So what do we know about an elastic collision? I know for a fact that momentum and energy must be, what's the word? Conserved. Classically, that means delta P equals 0 and delta E equals 0. That's what I know from intro 1. Collision experiments absolutely know that momentum must be conserved and energy must be conserved. Elastic collision, yeah. So let's discuss both of these individually. Let's do conservation of energy first. Delta E equals 0. That means E final must equal E initial. That means incoming photons must lose an amount of energy that equals the kinetic energy gained by the electron. Is that true? Where's the electron getting its energy from? From the collision, right? And so the photon must lose the same amount of energy that is imparted to the electron, which is why the photon must change color. I mean, they're X-rays, they're not actually going to have colors, right? You guys realize that, right? I'm just making that up. They're X-rays, they're not actually going to have colors. The scattered photon must have these three things: less energy, longer wavelength, and lower frequency than incident photon. Or mathematically, the same thing can be written as HF minus HF prime equal kinetic energy final minus kinetic energy initial, where this is for the photon and this is for the electron. The amount of energy gained by the electron must equal the amount of energy lost by the photon, where I know this is 0 because it wasn't moving, right, initially. So I can rewrite this as HF minus HF prime equal kinetic energy, the electron. Okay, now the next one was conservation of momentum. So look at this picture. How do we do conservation of momentum? We do momentas before equal momentas after, but we also have to do them from intro 1. If you remember, you have to do them on each of the axes separately. Do you remember doing those equations in intro 1? Yeah. Okay, are we ready? Which axis would you like to call? I'm going to stick with the normal ones. Ready or not, here it comes. So now we're going to do conservation of momentum. May I write this? Remember that picture? Initial, final. Initial X and initial Y, and then we'll do initial photon plus electron, and final photon plus electron. And I'll put an equal sign. Ready? Remember to breathe. Initial photon, XF over C. Initial electron, 0. Initial photon, HF prime over C cosine of phi plus P cosine of theta. Do we all understand how that works? Yes, I can. Okay, going back. Look at it. It's a head to tail rule. What is this? HF prime over C sine phi would be the P sine of theta. And this would be P cosine of theta and HF prime over C cosine of theta. Notice the arrows, head to tail rules. One of them will be minus when we put them into the equation. Which one will that be? The momentum for the electron going downwards will be negative. The rest of them will be positive. Do we all understand the head to tail rule? Yeah. Okay, a vector addition. Now, along the y-axis, initial photon along the y. Did it have anything in the y initially? Nothing, right? And what about the final? It will be HF prime over C sine phi minus P sine theta. Do we all understand where the pluses and the minuses came from?